This is the lesson for Algebra 2, and it is for the second day of 1-6. Our objective, if you look back to it, was that we were supposed to learn how to solve not just absolute value equations, but we're also supposed to learn how to solve absolute value inequalities. So as we take a look at this, most of the inequality business is going to be today. So the graph of the absolute value of x is less than 5 is all the values of x between -5 and 5. All right. Well, how do we think through this? Here's 0. And the distance of whatever it is we're supposed to be graphing from 0 is less than 5. So I'm thinking if I'm standing right here, right in the middle at 0, and I need to reach out 5 feet, I can actually do that in two directions. So I could go out this way, and I could go out this way. And then I have to look at the inequality to say, could I go exactly 5 feet? Should I go exactly 5 feet? And the answer would be no. There's no absolute value bar here. This says less than 5. So that means that we're going to need some open dots right here at -5 and 5. And that's how we graph this. Now hopefully you noticed, wait a minute, that looks a lot like that and sandwich that we were graphing the other day with inequalities. And you'd be absolutely right. That's exactly what we have to do when it is less than or less than or equal to. So with this one, we're at the 0 and we stretch out our arms both directions. But because this does have an equals bar right here, that means we need to include these two right there. So with less than or equal to, it is an and sandwich. Let's write that over on your side lines. Less than or equal to, and sandwich. Remember, we're talking about this. We've got our piece of bread, and what we're graphing is all the good stuff inside, the meat and cheese and mayo and tomatoes and lettuce and all that good stuff. So if we see the absolute value of x is less than or equal to, remember either one of these will work, we can make an and sandwich with this. If I go back up to what I've graphed in the blue, I notice, hey, my values are between -5 and 5. And I'm supposed to include those two endpoints. And if I go back up to the green one, I see that I still have those endpoints of -5 and 5, but I'm sandwiched between those two without including the endpoints. So that's how we do this. We're going to graph these as an and sandwich, and we are going to write them as an and sandwich. So problem 4 says, let's solve and graph the absolute value of 4x minus 3 is less than 5. And here's what we know. We have those prison bars right there, and we know we have to have two solutions. So normally if this were an equation, we'd set it up and say 4x plus 3 equals -5, 4x plus 3 equals +5. But from what we just saw on the graph up there, 4x plus 3 will be between -5 and 5. And what I need you to do is always think of this when you're setting it up as a number line, so that you're always putting the negative number over here on the left and you're always putting the positive number over here on the right. Now we solve this just like we did our compound inequalities. We're going to subtract 3 all over the place, and then we're going to divide everything by 4. Now that's a positive 4, so we don't have any flipping. So if you were sitting there thinking, okay, do we do the flip thing if we're doing inequalities with absolute value? If we have to. If we multiply or divide by a negative to solve, then yes, we do. So this will be -2 is less than x, which is less than 1/2. And they want us to graph this. We already know it's an and sandwich, so what we have to do is get a 1/2 on here and a -2. And then we have to determine whether or not we should be putting open dots or closed dots. So take a look at it. Notice it does not say equal to. So I'm going to go ahead and take these little green things off. and do that. And then I know it's an and sandwich because my x is between those two numbers. And there's my graph. So a lot of this we've already done. I mean, we already talked about compound inequalities and how they work. It's just that now what we have to do is continue on with it. You know, go all the way through, write them, solve them, because with absolute value, we always have those two solutions. This is a got it, so why don't you go ahead and pause the video and see what you can do with this one. This is a solve and graph. Once again, I'm looking at the sign here and I see that that's less than or equal to, and I think about standing right underneath 0 and reaching out in both directions on the number line to go 8 in either direction. So that'll be -8 is less than or equal to, this time, 3x minus 4, which is less than or equal to 8. Now we go ahead and solve. What we do to one, we have to do to all. So I'm going to add 4 all over the place, and get -4 is less than or equal to 3x, which is less than or equal to 12. And then I have to divide by 3 in all three places. So -4/3 is less than or equal to x, which is less than or equal to 4. Now again, really when we read this off, we should read it from the middle out and say x is greater than or equal to -4/3 and x is less than or equal to 4. But the way that we think about it is always left to right. So now, got to find some spots on this graph that look like -4/3. Well, you might want to write that as -1 1/3 to graph it. That might help you out a lot. So -1 1/3 would be right here. You label that either -1 1/3 or -4/3. It's not going to make any difference. And then we'll go over to the 4. Now the reason I didn't color them in yet is because this was a got it, and hopefully you're checking that saying, wait a minute, Cedar Home, those are supposed to be colored in. And you are right, they are. We do have equals bars. And this is an and sandwich. So we have to go ahead and graph that in there. So that was less than, because we were talking about distances that are less than some number from 0. Okay, well, what do we do for greater than or equal to? Well, that's different. I mean, let's look at what's going on. It says the graph of the absolute value of x is greater than 5 is all the values of x outside that interval of -5 and 5. So what they want me to do here is say, okay, if it has to be greater than 5, well, here's 0, here's 5. All of those are more than 5 units away from 0. And going to the left, all of those are more than 5 units away from 0. So do I include the 5 in the -5? Nope, no equals bar. There it is. That's not an and. That's not an and sandwich. We had two compound inequalities that we worked with earlier, and that was and or. So this graph has a cutoff at -5 and goes to the left forever. So x is less than -5. There's no overlap, so this is not an and sandwich. This is an or. X is greater than or equal to 5. Now remember when we talked about this, we are graphing to the extremes. It's the extreme heat and the extreme cold in Minnesota. They're always going to go out to those directions. So the graph matches what we have for an inequality. All right, let's go down to the next one. The absolute value of x is greater than or equal to 5. Well, our 0's in the middle. Here's our 5, going this way forever. There's our -5, going that way forever. And we have greater than or equal to, so we're going to go ahead and close that up. And again, we stop for a second and think, okay, how would I write this as a compound inequality? Well, we'd say x is less than or equal to -5, because whenever we have to do this extra shading, we have the extra equals bar. Or x is greater than or equal to +5. So whether or not we're talking about greater than or equal to, those are ors. Now that's one of those things you can either reason through by using a number line, or you're going to have to memorize by the time we take the test. And that is absolute value with less than, or equal to is an and sandwich. But absolute value with greater than or equal to is an or statement. And for that, we're always making sure that our arrows are going to point to the extremes, going to point to the far left and the far right. So notice in the blue box it says, hey, if you're going to use greater than, you have to write an or statement because you're talking about the extremes. Greater than means we're trying to reach out and we can't go where we need to go because it's at the extremes. We can't reach it from 0 on the number line. Problem 5. Solve and graph. The absolute value of 2x plus 6 is greater than or equal to 10. So first step, just like always, is isolate the absolute value. Well, the absolute value is all by itself. But with these, we now need to look here. And we need to say to ourselves, okay, then this 2x plus 6 is going to be less than or equal to a negative 10, or 2x plus 6 is going to be greater than or equal to a positive 10. So we'll continue on and we'll just solve these like we normally would. So 2x is less than or equal to negative 16. Divide by 2, x is less than or equal to negative 8. Or, let's subtract 6. 2x is greater than or equal to 4. Divide by 2, x is greater than or equal to 2. And then we can go ahead and graph this. So what we need to do is think, okay, I'm going to need my closed dots at negative 8 and at 2. But these are going to the extremes. Notice our arrows for our inequalities are pointing in the directions that we have to shade. But that only works if you always set up your inequalities so that the negative is on the left side. So like I said, always set these up just as you would put them on the number line. Our answer for negative 10 would be to the left, and our answer for positive 10 would be to the right if we had a number line right in the middle of the smartboard there. So those are really good problems, which, by the way, we need to get a little practice at. So there's one for you on the next page, and that is solve and graph the absolute value of 5x plus 10 is greater than 15. Stop the video, pause it for a little bit, and try this one. I look at this problem and I realize it does have absolute value. It has greater than. So this has to be an or statement because we want things that are farther away from 0 than 15 units when we put it into this. So if I stand at 0 and reach out in both directions, I can't grab all that stuff because it's too far away. So again, we set up our negative, and notice how the sign is backwards because it's a negative, and our positive, because again, those arrows have to point to the extremes, going in either direction. All right, let's subtract 10 from both sides. 5x is less than negative 25, divide by 5, and x is less than negative 5. Or, let's subtract 10. 5x is greater than 5, divide by 5, and x is greater than 1. So what we have to do is, these are not going to have closed dots, they're going to be open. There's no equals bar. So open dot at negative 5 out to the extreme, and then open dot at 1 out to the extreme. And there's our graph. So this is a definite, hey, we're going to see one or both of the greater than or less than inequalities with absolute value on the test. So keep that in mind. Now this one says, with a partner, match the statement with its graph. Some of you are at home all by yourself. So I'll be your partner. Let's look at this one. So what I would do is I would look at the graphs and figure out exactly what's going on. So as I look at A, I realize that's going to be an or. All right, so ors, those have to come from greater than or equal to. But these are not colored in. It has to be greater than. So the absolute value of something has to be greater than something. Well, we're using x for our variable in all the answers here, and we notice this distance is 4. So the absolute value of x is greater than 4. This is A right here. Let's take a look at B. B is definitely an and sandwich, so we know our absolute value should be inside two different things. But we start thinking, wait a minute, where do we get that from? Oh, that's less than or equal to. Okay, so let's see here. They didn't include the endpoints. There's no shading there. It's going to be less than. So absolute value of x is less than something. What's the something? 4 units this way and 4 units that way. So the absolute value of x is less than 4 is B. All right, let's look at C. C is definitely an OR. So if it's an OR, it's greater than, or equal to. I notice these are colored in, going to be greater than or equal to this time. And again, I take a look at this and see, oh, we're going back with the 4 again. And yeah, if you look at all the answers, you see it's always 4. So really, all we needed to do was figure out that was greater than or equal to. And so C should go right there. D just has 2 dots. Well, if it just has 2 dots, then it's not an inequality, because inequalities have to do the and sandwich or graphing to the extremes. So that means it can't have a less than, a greater than, a less than or equal to, or greater than or equal to. It has to have an equals. That's D. So this is definitely D for number 1. All right, E, an and sandwich. So that's less than, or equal to. Okay, well, they did shade in those endpoints. So it's not that one, it's this one. And again, absolute value of x less than or equal to 4 units this way, 4 units that way. It's going to be 4. And of course, process of elimination. There it is. So we could go with the graphs first, or we could take the equations, set them up, see whether or not they're ands or ors, and go from there. Now, what do we need this for? Well, this is actually something that's used a lot. One of the things that gets advertised for jobs quite a bit in our area is going to be quality control officers or quality assurance officers. And what they do is they take product off of the assembly line and they check it to make sure that it meets the requirements that their boss says it should meet. And that's called tolerance. Tolerance is what they're measuring. It's half the difference of the maximum and the minimum accepted values. So what they do is they ask the boss, what do you really want? And the boss says, I want it really, if it could, I want those Cheerios to be exactly 14 ounces. That's what you have right there. Is every box of Cheerios going to be exactly 14 ounces? No way. One more Cheerio over the top and you're done. So are they going to say, hey, let's not send out the Cheerios boxes that aren't perfectly 14 ounces? No. They're going to say, we want you to be within a half an ounce. They don't want to accidentally put too little in the box because they'll lose customers. They definitely will lose customers. And they don't want to put too much in the box because then, of course, they're losing money. So they have a tolerance and they try to stay within a range that's pre-established. So whatever the boss is willing to do. So our example is we want to cut a piece of wood 6 inches long, but we will use it if it's between 5.9 inches and 6.1 inches. So this means that the length of the wood right there is between 5.9 and 6.1. Now notice, they told us in the problem that it's supposed to be 6 inches long, but right here there's an L. That's because we're supposed to be able to think our way through that if we need to, where we could say, well, it's supposed to be smack dab halfway in between the other two. So what do? We take its average. We figure out how far are we supposed to go on each one of these sides. So you could do 6.1 minus 5.9 and then divide it by 2 and see that it's supposed to be 1/10 off from each side, which of course would tell us that this is a 6. Or you could take 5.9 plus 6.1 and divide it by 2. You're still going to get 6. So why do that? Because here's what's happening. The person that's the quality control officer is doing this. They're taking a box off of the conveyor belt. They don't know its weight. Let's put L there for weight, or in this case length of the wood. And what they're doing is they are trying to see how that compares to perfect. And a perfect here was a 6. But they will accept it if it's within 1/10 of an inch in either direction. And that's what that says. I mean, because if we were to solve this, we see that it's less than or equal to. Less than or equal to is that and sandwich. So L minus 6 would be sandwiched between, and then we'd have negative 0.1 over here and 0.1 over here. And we know everybody would add 6 all over the place. So this would be 5.9 less than or equal to L less than or equal to 6.1. And that's exactly what we needed. That was exactly what we needed. So problem 6 says, in car racing, a car must meet specific dimensions to enter a race. It has to be just so big, just so heavy. Suppose the desirable height is 52 inches, but cars will be accepted as long as they're between 51 and 53 inches. Write an absolute value inequality to describe the cars allowed. So let's start with this. We're talking about the fact that the desirable height is 52. So here's what's going on. The quality control, quality assurance person, in this case it's probably the inspector, comes along. And right now he doesn't know the height of the car. So we're going to use H for that. But what he wants to make sure of is this, that if he takes the height minus 52, it's within, and we look at these two numbers to see how far off we can be. Well, 52 is 1 away from 51, and 52 is 1 away from 53, so within 1 inch. And then we think, well, how do we show that within? Well, that's going to be less than or equal to. Now, why does it have the equal to? Because it could be exactly 1 inch, and they'll accept it. They didn't say that it had to be under 1 inch from both sides. So write an absolute value inequality to describe the cars allowed. Let me make this a little thicker so you can see that that's absolute value. And you probably wouldn't want your inequality to have any labels in it, but you'd label it when you figured out whether or not it worked. So here's what the quality assurance officer does. They come out and they measure the height of the car. And they think, how far off is that from 52? So they're doing a little subtraction. And if that is within 1 inch or exactly 1 inch away from 52, then they're okay. Everything is good to go. So let me get you the day 2 assignment, because we have just completed the second part of the objective, which was to learn what to do with absolute value inequalities. So go ahead and write that down. And remember, definitely going to see 1, if not 2 of these on the test. You have to make sure you know how to do these. You have to know that absolute value with less than or equal to means you're going to make an and sandwich, because those distances have to be closer in to 0. And then if we have greater than or equal to, well, those are going to go out to the extremes, because we're talking about distances that are farther away. So that is 1/6 day 2, and that is the last section for this chapter.